Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to go over on how to graph a function with a higher degree and including finding its characteristic, the domain range, and relative minimax, and behavior intervals, and including zeros. But mainly today, we're going to try to graph and find all these things using not our graphing calculator, but using another application which is called Desmos. Okay, so first we have a problem here, which is f of x equal to negative x to the fourth minus 2x cubed plus 15x squared. Remember, guys, these are solvable manually with a graphing calculator, but now we're gonna do it with Desmos. Okay, so first open your Desmos. Go to Desmos calculator and graphing calculator. So the problem that we have there is negative. So you can use the keyboard, the keypad here in the lower left, okay, if you need to. So I'm going to type in here. You don't have to type f of x, just type in negative x to the fourth. Caret is shift 6. That will make it the exponent or the superscript. Right cursor. Minus 2x. You can also write 3x's. That means x cubed, but I will just use a shift 6 to show it to you. And plus 15x shift squared. Okay. But before we continue here, let's look on the equation. What are the things that we know function with fourth degree? So we know the degree here is uneven. The degree is on fourth, or called quartic. Quartic. We know that's an even. Okay. If that's even, the leading coefficient here is negative. So the leading coefficient is -1. So we know since it's even and negative, we expect that they're both pointing downwards. Okay. The other thing that we know here is that the end behavior on the left, as x approach the left side, negative infinity, the function f of x is going down, so approaches the negative infinity. In the right side, on the right side, as x approach the positive infinity, the f of x approach also the negative infinity because they're both pointing down. Okay. If you cannot see the entire thing here, you can just minimize it. Okay. And scroll it down. There you go. All right. Just by looking at my graph here, how many turning points do we have here? We have 3. 1, 2, and 3 there. There are 3 turning points. And what's the degree of my function? Is fourth degree. Remember, the most number of turning points you can have is always 1 less of your degree. In this case, we have 4 degrees, so the turning point is 3. Okay. There are 2 relative max. Those are your relative max. It's -3.6. We can round up nearest tens. -3.6, comma to 119.8, and the other one is 2.1, comma 28.2. Okay. So I'm gonna write that down under my relative max. So my relative max value are -3.6, comma 119.8 and 2.1, comma 28.2. Okay. What about our relative mean? The relative mean is the one that goes down there, which happened to be here. It's 0. Okay, 0, 0. So for my relative mean is the 0, 0 there. Okay, very easy. Okay, so let's find now our increasing interval. Okay, if we analyze the graph here, the graph looks like, oh no, the graph Let's find the zeros. Let's find the zeros now. Zeros. Hit the home button. That will bring me back to the standard window. The zeros are the x-intercept. It's right here, right there, and there. If you notice, at -5, it cross. At 0, it bounce. At 3, it cross. So there are 3 x-intercept, but we have 4 as our degree. So that means we have a multiplicity of 1 to the -5, a multiplicity of 1 to the 3, and multiplicity of 2 to the 0. So in our table, I'm going to write here our zeros are -5, +3, and x equals 0, multiplicity of 2, because that's where it bounces. Okay. All right. So there you go. So let's look at our intervals now. In our interval here, we know that it crossed at -5, 0, and +3 here. The graph looks like something like cross that, very high there, and bounce to the 0 and go back down there. Okay, should be a little higher there. Okay, but anyway, we know that this point here, these two purple points is our relative max. Okay, and this yellow orange point here is our relative minimum. When we're finding for the increasing interval, we look at the increasing portion, and that the graph is increasing here in the orange one here and the orange one there. Okay, remember guys that this point here is -3.6 comma 119.8. Do we need the y value? We don't. In reading the intervals, we only look at the x value. So I want to make sure that I'm going to cross it out so you don't look at it. And on the other relative max, it's 2.1 comma 28.2. And I'm gonna cross it out so you know you were not gonna look at that one. And in our relative minimum, which is 0, 0, I'm not gonna look at that 0. Okay. So how much is our, or what is our increasing interval? Increasing interval started here far left. So that means started from the -infinity, comma, it's gonna go up, 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 and stop there. What is the x value right there? It's the -3.6. Union, it also going up here from 0, going up, 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 stop. From 0 to 2.1. Okay? And those are my increasing interval. Where it's going down. It's going down right here. Let's use a green one here, a neon green. This one here is decreasing. It's decreasing also right here. So again, remember we only look at the x value. We start here at -3.6, -3.6, and it stops at 0, union, and it start going down from 2.1, going far right, which is the positive infinity. And last one here, for our domain, since we have a graph on the left side, we have a graph on the right side. That means our domain goes from left to right, from -infinity to +infinity, or all real numbers. The range here is going to be different. It's not going to be all real numbers because we have a graph on the far bottom and the lower portion of the y. But what's the highest point of the graph here? The highest point is this one here, which is the y value of your relative max, the absolute max there. So that means you start from the bottom, which is start from the -infinity up to 119.8 bracket. Okay, and that's how you find the polynomial function and find its characteristic. And as always, kaboom.